So welcome to MRI Global's Magellan webinar series. This is our Navigating Scientific Challenges in COVID-19, where we'll be going through, this is the 6th and last of our webinar. We've had several others that are available on our website to review. We're just sort of reviewing the science and technology approaches that we're working on here at MRI Global to address COVID-19 and as well as other emerging relevant health issues around the world. And so today, we got one more. Hi, John. Just getting started, so running through the intros. So today's presentation is Mobile Labs, Projecting Science to the Front Line. I'm Joe Russell. I'm a senior scientist here at our Gaithersburg, Maryland location. And I'm joined today by Chris Hollers, Associate Director, and Peter Anderson, Senior Engineer, who both work at our headquarters in Kansas City, Missouri. And so we're looking for this to be a two-way discussion. You know, we're going to go through our slides and our information, but please, if you have questions, ask them freely. We're happy to discuss any and all elements as we go through them. Very casual atmosphere. So let's start off with an overview of our roles. So myself, I'm a senior scientist here at in our life sciences division in Maryland. I work in our microbial genomics and bioinformatics team. So doing a lot of the data science around genomics, information sequencing. I also am heavily involved in our portable lab platform development. So you'll hear a little bit about that as we go through our slides. Chris, you want to talk about yourself and your role?
Yeah, absolutely. Thank you, Joe. So I'm Chris Hollers. I'm an associate director in the Intelligence, Surveillance, and Reconnaissance Division, which is primarily focused here in Kansas City, Missouri. I'm a chemist, and I have a PhD in chemistry from the University of Kansas, and I've been doing research scientific research, development, as well as program management for 20 years. And so I primarily support multidisciplinary teams, biologists, chemists, mechanical engineers, electrical engineers, every variety of technical staff, and in solving large-scale complex problems for the U.S. government. So, so I'm a business development. I have business development responsibilities as well as resource management and program management. So certainly I'm glad you guys are listening in today.
All right, thanks, Chris. Peter, you want to introduce yourself and what you do here?
Yeah, so my name is Peter Anderson, and I am a senior mechanical engineer here at MRI Global. I've been with the company for a little over a decade, and so like Chris said, you know, we work very much on teams that are involving chemists and engineers and biologists, but I'm also lucky enough to be the lead engineer for the CBCS program.
All right, great, thanks guys. Okay, so as I said, free-form discussion, casual atmosphere, feel free to ask questions as we go through, but we're gonna go ahead and start the slideshow here. Let me go ahead and share my screen. All right, there we go. Hopefully everybody can see these slides full screen. So just a quick background about MRI Global itself, if you're not too familiar with us. So we were started in 1944 in Kansas City, Missouri, as a scientific research institute, nonprofit. We've grown since then to a number of programs in chemistry, physics, engineering, biology. Our footprint has grown to several different locations now. I'm in the Gaithersburg, Maryland location. We have locations in Virginia, North Kansas City. We also co-manage the National Renewable Energy Laboratory out in Colorado. But today we're going to talk about our mobile laboratory program. And so this has been a heavy business area for MRI Global for a long time. We have a lot of experience in this, in building these capabilities that are mobile. They can be built up, put on the back of a plane, brought into country, stood up and operational in under 72 hours. So we supply analytical capabilities, and provide actionable data for infectious disease surveillance, force protection, intelligence operations, sort of the whole gamut of operations that you would need a mobile laboratory platform for. We've probably done it. This is some pictures of our mobile labs being deployed to West Africa, down on the bottom left there during the Ebola crisis. Also some of our mobile laboratories for the military in the middle and on the right there. And again, this is sort of more detail on our operations in West Africa during Ebola. So a little bit more broken out information on what those mobile labs entailed. So you could see we had here the master mix and PCR module. We had the sort of command module, a sample receipt module, the decon and shower. And so in less than 60 days, we were able to design these for this particular crisis, develop, construct, deploy, and then we staffed these throughout the outbreak 24/7, processed, I think several thousand samples in 3 separate countries, so Guinea, Sierra Leone, and Liberia. And so I'm going to go now into, I think I have actually the wrong deck. Yes, I do. Here we go. So Chris, I'm gonna hand it off to Chris to go through our Athena lab, which is sort of the next evolution of our work in West Africa. We've learned some lessons from that experience that affected the development of Mercury Lab, and also Athena, which is sort of the next evolution of our container-based laboratory. So Chris, I'll go ahead and pass it off to you and just let me know when you want to advance slide.
Awesome. Thank you very much, Joe. So Joe gave a great intro, and I'm going to try not to reiterate a lot, but we started about in 2003. So, over a decade ago, we started building laboratories for the Department of Defense, and they wanted to place these in austere environments all around the globe for the analysis, chemistry, biological analysis of intelligence components. Think of it like if it was possibly trying to identify specific markers on explosive IED components, possibly latent prints, possibly biometric type things, DNA, and then also looking at chemistry signatures that would be indicative of where that device was sourced or possibly manufactured or built or whatever. So, and across the gamut of all the bad things in the world, chemical weapons, biological weapons, as well as explosives, poisons, all kinds of stuff like that. Doing all kinds of intelligence capabilities, providing intelligence capabilities for these deployed laboratories. So again, over the 15-ish years, we've been, this has been a long-going program. It's still ongoing. We've been to over 12 locations around the globe outside of the United States. Some sites have been as large as 25 containers, providing a whole range of support capabilities like water purification, nitrogen generation, living quarters, in addition to laboratories. So anyway, we've deployed over 90 different containers, and they've been either they're still deployed, they've been given to host countries for them to use, and we currently have about 12 that's owned by the Department of Defense that's standing ready for them to stand up a site or a couple of sites anywhere in the globe at a moment's notice. So that's really the long history of doing work for the Department of Defense. And then Joe went into the detail on the Ebola response. That was actually funded by DTRA, and those laboratories were provided to DTRA from the Department of Defense. So they took Department of Defense laboratories that were primarily built for chemistry, and then they changed them into diagnostic laboratories that were used for diagnosing Ebola patients in West Africa. And Joe's already showed you a picture of a site, and then also talk to you about the, some of those details. So I don't want to go into those. But take-home message of all this is that we've been doing this intensively for over a decade, and we've been collecting information on if we were to design a next generation laboratory, what would we do different? Because all of these laboratories that have been deployed for Department of Defense, they're really kind of locked into a initial design that's only changed slightly over the past decade plus years. So we wanted to take a step to make a quantum leap in modifying the design of these laboratories, and that's really what I'm going to be presenting to you on the Athena platform. Next slide, please, Joe. So here's a picture of an example of Athena laboratory. I don't want you to get too tied into the exact specifics, because these are highly customizable units, and these are mobile structures that are built to be one thing, and that is a laboratory. Not the vast majority, or actually all of our competitors in this space. They're building mobile structures, and then they can be changed or morphed into a laboratory. This is really only built to be a laboratory. This would not be, there are lots of other solutions if you wanted to have living quarters or something like that, or office space. This would not be the solution for you, because it's highly specialized and there are less expensive options. So the example here is of and again, don't get too locked into any of these specifics. It could be built at a 40-foot size. It could be built in a 21-foot size if that's what you want, because these are ground up structures. These are not ISO containers that have been modified to a laboratory. These are ground up builds in the form of an ISO container. So that provides us the capability of doing a lot of different customization and adding different capabilities that you can't do when you're just taking a ISO container and you're modifying it. You have less potential for intrusion of water and air. It provides you can have much more control over the structural integrity, so you can cut down on vibration if your instruments are vibration sensitive, or if possibly there's some aspect of what you're trying to do inside here is vibration sensitive, and also durability. So in this example here, we have an expanding version. That's another thing there's no other solution out there that can take a modified ISO container and add an expanding section, because it just doesn't have the structural infrastructure to do that. So we can build an expanding unit that gets you 82% more floor space than a 20-foot ISO container. And also, in theory, you don't have to necessarily take all this, but you can get 40% more bench space. And this is still keeping the 20-foot ISO container footprint, so that way, shipping-wise, you're able to still ship it like it's a 20-foot ISO container, but you're almost getting the capability of 2 ISO containers at your in place. We have like double doors, so you can move in big equipment and things like that. Go ahead and switch to the next slide, Joe. So here's an example of one of these units deployed. We have also developed a custom trailer as an option, if that's what you would prefer, that allows you to move around. And this is showing, stairs that you can have, so that way you can have entry and also exit if you need to have an emergency exit in this case. And then you also have the capability of using this. If you have a custom trailer, you have the opportunity to use it to store the HVAC. You can also put the HVAC on the roof. You can put the HVAC on the ground. There's no real requirement here. It's just that the customer that this was developed for wanted to have it up on the perch of the trailer. So there's lots of different options here, and this is just one deployed example based on their requirements. Go ahead and go to the next slide.
Quick question here, if I could.
Absolutely, jump in.
Yeah. What's the weight of that?
That's a great question, and unfortunately, I'm going to guess off the top of my head.
Wheels.
Say that again.
I see 8 wheels, I think.
Yeah, I want to say that it's 13,000 pounds, but that is not a confirmed thing. So I need to, if you want me to get back to you on that, I absolutely can.
Yeah, I have a number of questions around weights and powers as we go along, but yeah, please continue. I will follow up.
So again, highly customizable. We have developed units that could plug into both European standard as well as US standard with an automatic switch that detects what you're plugged into and switches the power based on whatever your input is automatically. We've developed them most recently with just US power because they've been deployed for COVID diagnostics in the United States, so they weren't interested in European standard. Or we could also put in only European standard if that's what the interest was. It's really it's again highly customizable. The base unit, it's not required that you have it, but the base unit is also supplied with an uninterrupted power supply that's integrated, so you don't have UPSs underneath cabinets everywhere. It's integrated into the whole infrastructure of the electrical system. And so that way you have uninterrupted power and also the ability to automatically transfer to a backup generator if you exceed the UPS, which can be scaled to almost anything you want with a matter of cost. So next slide. So this shows the couple of discussions on the HVAC. The most units that you would look at for a mobile unit, you're going to have a wall mounted unit on the end of the ISO container. This limits the size of that wall unit, and it also it starts cutting into your footprint inside the mobile laboratory. And also it just doesn't provide very good airflow dynamics. So we found to have the option of having a skid mounted HVAC provides almost complete flexibility. You can change the ducting inside to get better airflow for comfortability of your analyst inside. You can scale this to use massive air conditioners of almost any size if that's what the heat load requires, either based on the environment or the heat load generated by the instrumentation inside. And it also allows you to even have 2 units if you wanted to. So there's lots of flexibility in the HVAC. And the latest version of the Athena, we actually have developed the provision in the latest version, which has yet to be deployed, to also go back and do a wall mounted if the customer did want that and had that requirement. So it's complete flexibility in being able to do this. So and provide the airflow. Next slide. I did want to say one. You don't have to go back, Joe. So I'm getting an echo. Is there somebody on their phone that has their device unmuted? Okay, that seems to. Yeah, there's some glitch with Teams in that. So
I do have a question.
Okay.
The question is can you do a AC mini split instead of having the self-contained unit outside with ductwork? Can you eliminate the ductwork and just have a split unit setting on the side of the unit instead of having a separate unit hanging either on the ground or on a trailer?
So I'm not probably the best person to answer that. Peter, is that something that you could answer? Peter's not intimately involved in the development of this product, but he's done numerous other things and he might be able to address that.
Yeah, sure. So there's some trade-offs to being, doing that type of a setup. It certainly can be done. We primarily use this approach for serviceability of the HVAC system itself. So you don't have refrigerant that is, running through, the split pack system. So it's really, we went with this approach purely from a maintenance and serviceability standpoint. But really, it's just a box, and so you can cool it in a number of different ways.
Yeah, the one thing I would comment is that the split unit off the side you'd have to remove it and replace it after transport. I see that as, just a complication, but it certainly is doable. Go ahead and go to the next slide. So So here's an example of an equipped Athena laboratory on the inside. I want to make sure I draw to some key features that are unique to this design. So this is a laboratory that's been deployed for the Department of Defense for COVID diagnostics. They're using these CONUS to move between military bases and trying to do widespread diagnostics of military personnel and contractors on bases. So just a couple of features here. So you can see in this example, they wanted to have 2 BSCs. Their workflow for the diagnostics called for 2 BSCs and 2 16-bay gene expert CFID gene expert modules for doing the diagnostics. And so you can see there in that upper picture, those are the 2 CFID gene expert 16-bay modules. And then in the lower picture, which would also be in the left of the upper picture, you can see the 2 integrated BSCs that they're using in this workflow. But this is just based on DoD's workflow that they defined for their analysis. The center row, you can have fixed infrastructure. You can also have rolling infrastructure. In this case, they wanted these to be rolled, and they only wanted a short length, whereas we could run almost the whole entire length just to have a walk around on one end if you wanted to. Notice the ducting is integrated into the wall, so that way you can have control on where your input and output is, and then also nice controllable LED lighting that's dimmable. You can change the temperature to whatever works for the analyst in there, trying to give them as much comfort as possible, because many times when these things are deployed, people are working possibly, 10-hour shifts back to back for 24 hours, three shifts. So you're trying to get the analyst as comfortable as possible. Another aspect is that the floor is stainless steel and it's flat. We have no step in going from the expanding version to the non-expanding version, and this, expanding side to the non-expanding side. And so this is a feature, again, that's unique to our product. I don't know of any other expandable unit anywhere that has a flat floor. And we found this to be really critical. The analysts in previous versions said, man, we're in rolly chairs, we're in stools that roll, and then you got this step that you're constantly have to deal with, or possibly infrastructure in the floor that causes the chairs to not be able to have full manipulation. So that really calls out a bunch of the features, as well as overhead cable management. We found that many times when these would deploy, they would just become a mess inside because you would just have cables running everywhere. And so providing the cable management up front really helps keep it clean and helps keep the analysts comfortable. I believe that's my last slide. We're going to have questions at the end, an opportunity for all topics. Is there any question right now based on the Athena, or we can wait until the end?
I have a question, but I can wait till the end.
Okay. All right, Joe, to you.
All right. Thanks, Chris. So again, I'm Joe Russell. I'm going to be talking to you about our Mercury Lab platform. So this is our, we envision this as kind of the spokes to the hub of Athena, a more portable platform that can go further afield when necessary. And so this became apparent to us during our experience in West Africa during Ebola, where we were processing thousands of samples, but we were hearing reports of hemorrhagic fever symptoms, folks with hemorrhagic fever symptoms that were upwards of 200 miles away from our clinic in Wayamba. And if it's rainy season in Sierra Leone, the likelihood of that patient or that patient's sample getting to our clinic is pretty low. And so, we wanted to develop something. How can we address this problem? Is there a way to expand our footprint in a meaningful way? And it just so happened that this experience was happening at the same time as this sort of paradigm shift that's been occurring in biology, biological genomics based hardware over the past 5 years. So there's emerging ultra portable handheld molecular biology platforms like the Biomeme 2.3 is a quantitative PCR thermocycler that you can run off of an iPhone. An Oxford Nanopore's MinION platform is a nanopore sequencing device. So that device there is about the size of a candy bar, but it can sequence a genome. And so this allows a capability of these advanced either environmental biosurveillance or clinical diagnostics capabilities far away from a traditional brick and mortar laboratory. I mean, when I was in grad school, the sequencing that I did for my PhD thesis was done on a device that was the size of a -80 freezer, and now we can do it on something that fits in your pocket. So it's completely changed, how, where, why we access biological information. But that you can't get around the logistics of some of this. Even though the footprint of these devices is small, the operational footprint is still not small. And so, a lot of times you'll go to conferences and you'll see folks talking about they're out in the field doing nanopore sequencing, and they'll put up a picture like this on the top left as, this is sort of the ideal, he's on the beach, he's in his board shorts, he's loading a MinION, he's going to go take a swim, get a tan, come back, and he's going to have his genomics data ready. But the reality is more like on the bottom right. When you go out in the field, to support MinION sequencing, you need cold chain logistics for your reagents. They got to be kept at 4 degrees. You need computational capacity. You need a pretty heavy duty computer to do the base calling and the analytics. You need power. How are you going to power these things? Even it's something as simple as a sturdy place to work. I mean, stuffing all of these things in a backpack and going out in the field and just sort of using the nearest flat rock to do, complex biological analyses, it certainly leaves something to be desired. I know that from experience. And so we had a few field trials using these tools, particularly down the Everglades. We had a successful field trip down the Everglades where we did some analysis of Everglades virus, which is a strain of Venezuelan equine encephalitis virus, which is a pretty nasty virus that was weaponized during the Cold War. But there's a strain of it called Everglades virus that's circulating around down the Everglades. And we went down there with a team of entomologists looking through mosquitoes for it. We ended up finding it, but we had meant to do it in the field we brought a Biomeme and PCR primers and a MinION and all the things that we would need in a backpack. And out in the field, trying to conduct those workflows out of a backpack, it wasn't reproducible. It didn't feel safe. It felt very ad hoc. And so what we wanted to do was build a platform that didn't compromise on the logistics, but also didn't compromise on the portability of these platforms. And so we came back from that trip. We hit the drawing board. We went through a few iterations before we got to this version you're seeing here. This is sort of I call it our version 0.9, where we essentially built a fold-out laboratory in a off-the-shelf, essentially a roadie case. This is a type of case that they use to transport speakers and amps for concerts, to music venues. We sort of gutted it and built in all the logistics that we would need for doing these workflows out in the field. So you can see here in the top left, there's 2 separate Credo cubes. So those are cold chain storage. They're not unpowered. They work off of phase change cooling material, so they can keep temperature for up to 96 hours. The top one was a 4 degree, and the bottom one was a -20 degree cooler. Below that, you'll see our lithium-ion battery brick that we were using for this version. I took this version to Addis Ababa, Ethiopia for a training event, and I had no problem with Mercury Lab, but it was going to cost me about $4,000 to get my 950 watt-hour brick of lithium-ion battery power to and from Ethiopia, which is about 4 times as much as the battery cost itself. After all the Samsung phones started exploding on planes, nobody wants to take that much lithium-ion battery on a plane. So we've iterated that. There's a number of kicking the tire trips that we took with this version, and a laundry list of things that we wanted to update on the next version to improve. And that was one of them. We wanted to make sure that this was easily transportable, and would have solutions to support all the logistics you would need. And so this is our current version, our version 1.0, sort of our go-to-market version. These are commercially available now for order. Our inventory should be here at the end of the month. We shifted our power strategy, so you can see there now we have a car battery, 12-volt car battery. So everywhere in the world, no matter where you go, you will be able to find cheaply and readily available good old-fashioned car batteries. So rather than having to worry about shipping or transporting a large lithium-ion power brick, we built in a pure sine wave AC/DC inverter into the system. So it's up to the user. They can transport the lab. Just when you get there, you're going to have to find yourself a car battery, but that will power all the workflows that one would want to field on this for, depending on what you're doing, between 10 to 12 hours for sequencing, longer if you're just running PCR. We drastically improved the computational capacity and the interface on this version. So we've included a GPU, so a graphical processing unit, to complement the CPU that we have on board. So the CPU is an Intel NUC, has 2 terabyte solid state drive, 64 gigabytes of RAM. It can run any operating system that's the user prefers. We like Linux just because it's nice for bioinformatics, but we can run whichever the user prefers. But that's complemented with an external GPU, which it's an NVIDIA Quadro RTX 4000, so that has 2,304 CUDA cores. So the GPU architecture is much faster at base calling. So when you're generating sequence data off of the MinION, to convert the electrical signal that comes off the MinION into actual sequence of base pairs is a pretty heavy lift computationally. So Oxford Nanopore sells a orthogonal dongle, a GPU dongle that you can use, but it's just for base calling. Or if you have internet connection, you can send your data up to the cloud, and their servers will base call it for you. But what we wanted to do is add a lot more flexibility so that a GPU, you have the GPU, you can use it to base call, but you can also use it for your analytics and any other modeling that you might want to do in the field. And so it allows a lot of flexibility and a lot of computational power. So any bioinformatics analysis that you're going to want to do, Mercury will be able to support it. Easier setup and breakdown. We've redesigned the way that the table folds out and is stored. It's a lot more secure, and added more robust wheels and an axle, so it can handle those bumps in the field and city sidewalks a lot better. Improved the ruggedization, added more handles. We integrate our custom metagenomics analysis software developed by MRI Global. So we had a ditcher program called S2S, Sample to Sequence, where we developed an end-to-end metagenomics biosurveillance workflow meant for sort of rugged, austere laboratories, but nonetheless for a brick-and-mortar lab. Our colleagues in Kansas City developed the upfront wet lab part of that, and our team here in Gaithersburg developed the back-end bioinformatics graphical user interface. It's sort of an easy point-and-click bioinformatics software suite to analyze data, and so that comes included and pre-installed. And various spill control and biosafety features that are built in. And just sort of go through the clamshell opening of this. This is sort of on the left, what this looks like packed up, ready to go. Has TSA approved locks. I've traveled with it to Ethiopia, Peru, all over the United States. It's been to Senegal. So it travels well. It's taken its licks. It has a few scars on it, but it's still ticking. That was our version 0.9. We just got in our 1.0, and we've added even more ruggedization. So I'll be taking it on the road as soon as the world situation allows. But we've definitely added a lot of rugged functionality to it. And so when you open it up, the table is stored in sort of opposite the Credo cube there in a foam insert, and just clicks into that hinge you can see above that vent I don't know if you can see my cursor, but here's a vent that vents the internal computational compartment that folds out. Here on the far right, you see that. We have our AC/DC inverter, our NUC, and our GPU on this foldable platform. We have LED lights, so above the computational fold-out cubby, and then up above the lab bench, underneath the monitor there's a LED light, so if you're working in low light conditions. This shelving here is actually where you see the pipettes and the mini centrifuge or pipette tips, etc. That's actually a foldable or a zipperable backpack. That's an insert. So if you pull that out onto the bench, you can zipper that up and remove that, and that's and hike further afield if need be. So if you have a biomeme or some sort of PCR device, handheld device that you want to take somewhere you can only get by foot, and don't want to wheel Mercury Lab there, that's available. And then there's an integrated battery monitor that'll advise you on how much charge you have left, how many watts you're pulling, and your runtime. And then there's 120 volt outlets. You can order these as US standard or EU standard. And then there's also 2 USB ports that are power only, not for data. So on the NUC, you have an array of USB 3.0 Thunderbolt Lightning ports for data. And so that's any questions on Mercury? That's sort of the quick rundown, and we can go through questions at the end. But if there's no questions now, I can hand it off to Peter to talk about the CBCS.
I'll just say this is Ryan from Southern Beams, and nice job on that design. Like, I've spent 10, 12 years building mobile and grid integrated energy storage systems, and I know the problems with lithium, also know the issues with lead, but to do that evolution that you did is perfect.
Yeah, thank you. Yeah, it was definitely we were excited. We were trying to figure out what we were going to do. Ended up going back to that classic is it's always
the image between the reality, that is my setup at Burning Man. A tent, canvas tent, a pop-up in front, the rest there. But I mean, sorry, more to come here, but wonderful work on that and the Athena too. So really enjoying this. Thank you. Please continue.
All right, Peter, do you want to walk through CBCS and just let me know? I'll advance the slides.
Sure. Yeah, you can go ahead and just go to that first slide there that shows the unit. So the CBCS, which is the Containerized Biocontainment System, was a system that was developed during the height of the Ebola outbreak in 2015. So we sort of realized pretty early on that the Department of State needed a way to safely transport medical care professionals that got Ebola back to the United States for the highest level of care possible. But the question is how do you safely transport a highly infectious person by airplane, for up to 16 hours at a time? And so what they needed was a container that you could create a negative pressure inside of it to safely contain the disease. So the result of that development was the CBCS. And so what it allows us to do is safely transport up to 4 critically ill patients along with medical professionals inside there that can actually provide treatment to the patients. But then it also keeps the aircraft and any personnel inside the aircraft safe from the disease. And so you limit the exposure to inside of the CBCS. Next slide. So there were several unique challenges to figuring out how we would actually design the system, because there's kind of a marriage of a few different components that you have to keep in mind. One is the biocontainment itself, which you can sort of base that off of just standard biosafety lab protocols. But then you also had to have this airworthiness requirement. And so what that meant is that it wouldn't interfere with the operations of the aircraft, but the system also had to be designed to survive crash loads. and the vibrational loads from being in flight, and also possible rapid decompression events. So it was we quickly realized that there weren't very many off-the-shelf components that managed to meet those requirements, and so it was essentially a custom from the ground up design and build. But what you see here in this picture is that the CBCS is divided up into 3 rooms. And so you actually have a airflow through all 3 of the rooms, which creates a negative pressure environment. And so you enter in from the right, and that's where the staff can actually be unsuited, and they can take a break there and have something to eat if they need to. You then transition into what we call an anteroom, and that is where medical professionals would actually don and doff PPE, and that room is held negative pressure to the staff room. And then finally you enter into the patient room, which is held at the highest negative pressure. And this is where the patients are located, and the medical professionals can be in there, but they are fully suited up, but they're able to provide medical treatment throughout the entirety of the flight. Okay, next slide. So we designed the system to be easily decontaminated. And the way we did this was using materials that are compatible with multiple decontamination approaches. And what we ended up doing was actually spraying on a flexible epoxy coating over the entire system, essentially on the inside. And this allows for decontamination, and it also eliminates any sharp edges or areas that would be difficult to decontaminate. We also designed, like I mentioned before, the system to survive crash loads and rapid decompression events. So in a rapid decompression event, you actually have pressure build up inside the unit, and so you would actually we need to be able to contain that pressure and bleed it through the HEPA filters. We do provide medical oxygen and emergency oxygen, and there is a battery backup system. And all of the components inside can just be removed and replaced if necessary. Okay, next slide. The primary aircraft that this was designed for was the C-17 and the 747-400, which is the cargo version of the 747. And we can integrate directly into the aircraft power, which is kind of a weird 400 hertz frequency, but we have onboard frequency converters. As far as moving this, the CBCS, it has the standard lift points and can be lifted by a crane or from a forklift. And it is based off of the, a 40-foot ISO container, but it is custom built from the ground up. Okay, next slide. So since the Ebola outbreak, the Department of State has done a number of extensive training missions. And what you see here is a training mission that was in the United States. And Chris and I actually got to fly along with this one. So we were able to see it in action. What this was trying to simulate was an event where a group of people came back from, whatever, if it was in West Africa or whatever, and then they dispersed back to their hometowns and then started to exhibit symptoms of whatever disease it may be. So then in this training mission, we actually flew around to a number of different cities, picked up these mock patients, and then transported them to facilities that are capable of treating that type of illness. And so, during the past 5 years, the Department of State has really developed and sort of honed in their ability to operate the CBCS. which has come in, to be very critically important, because if you go to the next slide, they have used the CBCS extensively to either repatriate or evacuate U.S. citizens abroad during this coronavirus pandemic. So you can see in the upper right picture, this was actually from the Diamond Princess cruise. So they flew over to Japan and picked up all of the passengers. And so anybody that was confirmed with coronavirus was could be transported inside the CBCS, and the rest of the passengers can just be in the cargo hold of the 747. And we know that they've flown several missions around the world, evacuating U.S. citizens and actually taking other foreign nationals back to their countries if necessary. So, any questions?
All right, thanks, Peter. So I think that's the end of our technical slides. At this point, we wanted to just sort of have an open discussion, Q&A. So if there's any questions anybody had,
John Holland, can you hear me?
Yes.
I'm just, how much of this is all a military application and government, as opposed to civilian?
Well, that's a broad question, I guess. So the Athena so far has been a lot of government supported contracts. Mercury itself, and I guess also a CBCS. Mercury itself, there's been some government interest, but also a lot of interest from outside of government academic labs, a lot of interest from field forward ecologists, private health clinics, agricultural.
What my interest is, I'm mostly interested in like PCR data, and our company is working where we have a disease that infects 3 billion ruminants, cattle, livestock throughout the world, and we are needing to know how to get diagnostic data. And that's why I'm looking at your thermocycle, or the handheld PCR. Can that operate as a standalone and then go to the cloud, or do you have to have it interconnect with one of your Mercury labs? No,
it can operate standalone, and I believe it has software that interacts with the cloud.
Well, that will be my biggest interest. I'll come back to you guys on that.
Yes. So Mercury itself supports a lot of third-party handheld devices. So we work closely with BioMeme. We have a good relationship with them on several other existing contracts. So we can absolutely put you in touch with them. Oxford Nanopore, we don't make or sell their devices, but they integrate well with Mercury. Mercury's meant to be sort of device agnostic, but give you all of the logistical platform you would need to effectively use those tools in the field.
Great, thank you.
Yeah, Ryan, please
go ahead.
Yeah, I was just going to make a couple comments. This is Ryan from Southern Beams, and Southern Beams is a articulating solar company, and I've set up a number of other companies. One was called Jelly. We do software control systems and design systems for energy storage at residential, commercial, utility scale, some mobile applications. And I kind of came to build out this next company to do basically how much solar can we get in a 20-foot container. Because I've been deploying systems of all different sizes at Burning Man and across the world, and in virtual power plants across residences, and we do the control system on the battery system at Fort Collins. It's the world's largest behind the meter lithium-ion battery.
Oh, wow.
And so that's 4.5 megawatt, 8.5 megawatt hour. And
Wow.
we're optimizing between the energy and the demand charges of the utility and the two different long-term contracted powers from WAPA and Pueblo Hydro that all actually have demand too. So, I mean, so I come from a very, controls and software and financial controls, and I have a PhD in chemical engineering. So I really appreciate kind of the PCR work. I was going to do a postdoc on doing a PCR that went to Mars. But ended up I was a postdoc for the director in Central Intelligence in 2001 and worked on micro batteries and really on the integration of micro batteries with micro communications and computing systems for like multi-hop test type stuff.
Oh, that's really interesting.
Yeah. So,
I'd love to keep in touch. I mean, we're trying to, lithium ions works great, but I actually been trying to follow the progress on solid state batteries as well, and thinking there might be a role there for mercury.
I have a number of patents around solid state batteries, and Jelly was going to be a solid state battery company until I realized we needed an energy operating system before we just enable batteries and gen and uses, be useful. But like, I think solid state battery, I really like what you did with concluding to use a 12-volt battery too.
Yeah.
To solve the airplane problem and all of that. Otherwise, you need to have 100-watt-hour blocks, and the DC power electronics don't exist there. So I think that was right. What really drew me and why I'm here today is like because I saw Athena with the side expanding out, and my team over at Southern Beams and figuring out how to roll out 20, 30 kilowatt of solar automatically was a heck of an engineering feat. And what we're doing is really kind of getting it for the generator rental market. We believe we've made something that replaces a 20 to 50 kilowatt generator, because also experience at Burning Man and residential systems and smaller systems, people kind of they buy those aren't really service items. It's not really, it's hard to kind of you end up with a 12-volt battery,
right?
But for the Athena systems and your other the biocontainment system, super cool. And 400 hertz, I did not know that's what airplanes ran on. Thank you for that. Pretty knowledgeable around the space. So, but those are taking larger loads, and we work a lot with Burners Without Borders, which has also exposed us with a lot of just response and emergency response and activities, and realizing it's really hard to have diesel generators in there, and there's really no good solar other than 2 or 4 kilowatt solar on a trailer. So it's solar's always been out and so you always had to have a generator here. And so that's really what I kind of went after, is not the 1, 2, 5, 10, but something that could be a 25 or a 50 and stackable instead of 20 foot. So it's really limitation on how much solar you can get in there.
Yeah.
So I don't know, I really respect the work you guys do. And this is cool to kind of listen, and thank you for being so open and sharing. We've tried to do the same thing over at Jelly, being open sharing on that. But also, I guess my question to the gentleman's first question was you've done a lot of DoD and special response, and you have about 100 units, and that's significant. They're probably all networked into the max. But are you seeing more pull from mobile hospital, or the hospital just needing now new outside rooms, or something that's more on the commercial side that can be financed and is a thing? I can imagine you're getting more of these biocontainment requests to build those too. I mean, I don't know. I'd be interested in that and how to pair technologies and go to market. But yeah,
I know I've had a few inquiries myself for sort of mobile health. But I think it's been more for Athena just because of the biocontainment ability that's built in there. So Chris, I don't know if you had.
Yeah, I was going to comment. There's been a tremendous amount of interest, but it's really, unfortunately, really the money is flowing more through the government than it is through private organizations. We think there's definitely a market for a health system, maybe having a triage unit. See, the issue is that luckily, thank goodness that COVID doesn't have the symptoms and the mortality rate of Ebola. If we had a situation where we had Ebola mortality and people crashing out, in horrible fashion, and the infectious
fear, yeah,
and the infectious characteristics of COVID, it would be a completely different ball game, of course. So my problem is that I shouldn't say the problem. What I'm seeing, and I'm seeing a lot of leads, but the issue is that COVID just isn't nasty enough to push people over the limit necessarily to require to have a triage unit for their entire health system. So that way they don't bring that it's not worth the risk isn't big enough to pull that person into the emergency room right now. Does that make sense? Like they can deal with having a COVID positive person come into the emergency room. If it were Ebola, it would be a completely different story. So that risk versus reward, and luckily with this pandemic, it's not there. I mean, I don't ever want to see that in my lifetime or anybody's lifetime. So
I guess I see that aspect, and I guess like I'm still striving to see like to kind of find the real commercial piece, because I can also understand like the amount that you probably make on these containers is significant, and like that margin's awesome. But then like to actually make a commercial product, A, maybe the market's not there. B, it's not as much margin. It's a totally different business. But like I went to get my COVID test, found this little lot that's being undeveloped. There's like a bunch of tents, a couple trailers, whatever they're doing, and 240 kilowatt generators. I'm just like, I don't know what market you're serving, but I'm kind of getting a feel like these are kind of here to stay. And when I go by hospitals, they have like, outside areas and rooms. And what I've also realized is like, doing solar battery at a 20 kilowatt, solar with 50 kilowatt burst power, 20 kilowatt with 45 kilowatt hours, is cheaper to install that than it is to actually build it into the building. So I think there's like this aspect of like, it's probably actually gonna be cheaper to expand your hospital or have these other safe quarters, like that. But I don't know, I would love to investigate that with you.
Yeah, so I think we're in agreement. I think that right now, these hospitals are operating out of, I'm sorry, my phone is going off here. They're operating out of these tent structures and stuff because it still feels that this might be a temporary situation. Certainly, if we're still doing this in the spring, I think that there's going to be many more hospitals and companies going to brick and mortar mobile laboratory type structures, and that's really the market that we're in. But I just feel like people are still waiting to see if this is something that is going to require an enduring capability to keep up with this in the future, or is this going to all be off? And I think that people are starting to realize, and corporations and health systems are starting to realize that this is not going away. And we're going to still be dealing with this probably 12 months from now, assuming that a vaccine doesn't just take it out.
Even past
Facebook just said June, not coming back till June next year.
Yeah. But even past that point, I mean, once COVID's done, I think the new normal that they keep talking about, I think there's going to be an after action sort of report, autopsy on the response to this. And I think, there's going to be a lot of investment in the infrastructure.
It's going to be a completely different level of preparedness.
Next one. And it's probably going to be a lot of mobile infrastructure.
Yeah.
Right? That's what we're trying to prove at Burning Man, is that we have a 70,000 person city worth of all mobile, renewable, regenerative infrastructure. It can disperse, it can come back together, and it doesn't need 2 or 3 days either. Because that's the whole other part. Like, we can build 20 kilowatt arrays, but it also takes 2 or 3 days.
Yeah.
So, sorry to interrupt you, but yeah.
Yeah, no, it's
right.
So we got this has been an awesome conversation, guys. I mean, and Vicki, I really appreciate you guys being involved in this.
Good. I need to deconnect.
Yeah, we got
Yes,
our
contact information. It's sitting there on the screen right now. Make sure you reach out to one of us if you have additional questions. There's also 5 other webinars that are on our website. You can just go type in Magellan in the search and you'll hit on the screen. This will also be on there eventually. It might take a couple of days, but there's a lot of information on our website if you want to dig in a little deeper.